All right. So greetings, YouTube. Beautiful mind here. And we're continuing our discussion on chapter 2, exponential and logs. And we're going to be talking about section 2.2, derivatives of exponential base E functions. A few objectives here. We like to differentiate exponential base E functions and solve applied problems involving exponential base E functions and their derivatives, okay? So we have this theorem. It says the derivative of the function given by this is going to be itself, right? So that's just the derivative of E. F prime is equal to F, right? In other words, the derivative of E to the X is E to the X, okay? Let's see this in application. So we're asked to find these derivatives, okay? So then for part A, we're doing this thing again, okay. Probably need to reboot my system. I don't know, I think that means the battery's getting low or something. Not sure why it does that. Okay. So then for part A, we have y equals 3 e to the x. So then the derivative here, or in other words, our dy by dx, it's just going to be itself, 3 e to the x. Okay, part B, we have y equals x squared e to the x, okay? So then our dy by dx, see, so we got to use the product rule. The first times the derivative of the second, which is this, plus the second times the derivative of the first is going to be this. We can essentially stop there. Okay, I'm going to work on part C over here. Okay, we have y equals e to the x over x cubed. Okay, so I'm going to use the quotient rule. So this goes the bottom or here. So our dy by dx is going to be the bottom times the derivative of the top minus the top times the derivative of bottom over the bottom squared. Okay, we could factor out that e to the x. I don't think anything cancels. Okay, we can factor out an x squared from both. We can factor out a x squared e to the x from both terms, right? So if we factor out x squared e to the x, the first one leaves us with x. The second one leaves us with a 3. And then this x squared turns this 6 into a 4. Okay, so then ultimately we get e to the x minus 3 over x to the power 4. I think it started to run out of space a little bit. Okay, let's see. We got 3 e to the x, we got this thing and this. Let's see, how do we do? You see the 3 e to the x. We got e to the power. Okay, so they went on and factored out the e to the x on both of those terms. Let me see. That's fine. And then you see the simplified form. I think we got the same thing. Okay. I'm going to leave the quick check as an exercise for you. And then we have this theorem. So now this is like an extension. We saw in the previous example where the derivative of e to the x was itself. So now with this, suppose instead of the exponent being x, suppose it was like the exponent was a function. So then essentially what we're doing is like a chain rule, right? So the derivative of e to some function is going to be, again, just itself times the derivative times f prime, right? So it's like the derivative of the outside function times the derivative of the inside function. Another way of looking at it, the derivative with respect to x of e to the u is going to be itself times du by dx. The derivative of e to some power is the product of e to that power and the derivative of the power. Okay. Oh, I thought I guess I'm maybe missing a slide. Okay. Let me do the following. Copy. Paste. I guess I didn't save that slide when I was working on it earlier. I want to copy, paste. I just want to hide all of this stuff. I know we can see it, but we want to try to arrive at those conclusions. Okay. This is fine for now. Okay. So then for part A, it's a little bit better. This is fine. So for part A, if we're going to find dy by dx, so the derivative of e is itself, e to the power of 8x times the derivative of the exponent. So the derivative of 8x is just going to be 8. So I'm actually going to write it. I'm just going to put the 8 in front. I'll work part B here. So then our dy by dx, let me see. So the derivative of e is itself. So we're going to have e to the power of negative x squared plus 4x minus 7 times the derivative of that exponent. That's going to be a negative 2x plus 4, right? And I think the last term, the derivative of constant is 0. I'm going to leave it there. Copy of this one, copy. Paste. This dog is hilarious. Okay, part C. She hears anything, she's like, who's there? How dare you disturb me? dy dx, okay, the derivative of e is itself, so e to the power of root x squared minus 3 times the derivative of the exponent. So we got to use the chain rule. The 1/2 comes down. We're going to keep this x squared minus 3. Now we're going to say to the power of negative 1/2. Now we're going to say times the derivative of the inside part of that. So we essentially use the chain rule like twice, right? Okay, we can simplify this down a little bit. This 2 is canceled by this 1/2. Okay. So then ultimately, on bottom, we're going to have what? The square root x squared minus 3. On top, it looks like we have x times e to the root x squared minus 3. Okay. Okay. So we got 8e to the 8x, e times all of that. Okay, let's see. 8e to the x, e times all of that, negative 2x plus 4, and then x e to that over the root. Okay. X e to the that over that. Okay. So far, okay, again, the quick checks, I just been leaving those as exercises for you. Man, what happened to my edits? Like, I didn't get any of my edits. I must have stopped kind of early inadvertently. I thought I got all of these, but maybe I did. That is a pain. Let me copy, paste. Usually, okay. So then all of this I want to get rid of. Is there another way to do this? Copy. Yeah, usually I get rid of this stuff so that it's like a clear crop. Okay. Okay. Okay, let's get this one to go. Did I skip one? Quick check. I think we just did that one, right? Okay. One other thing I can do. Let me see if this is a little bit better. It's a little bit more work. Actually. Let's cut that. Now, can I just clear the page? No. That's okay. Rotate, clear the page. And if I, that's okay. Okay, let me put it back. Yeah. And I want one more thing. Sorry about this, guys. Copy. Okay. So with this example, we're asked to find a second derivative of y with respect to x of this, right? So basically take the derivative and then take the derivative again. So if we're starting with y equals e to the negative 5x squared, then dy by dx is going to be itself e to the negative 5x squared times negative 10x, right? So then the second derivative, so the second derivative of y with respect to x, we're going to use the product rule. So we're going to say the first, which is this, times the derivative of the second, which is going to be this, plus the second, which is this, times the derivative of the first. So that's going to be e to the negative 5x squared times negative 10x, right? We could factor out that e to the negative 5x squared. Okay, let's do that. E to the negative 5x squared. That's going to leave us with 100x squared minus 10. And we could actually factor out a 10 as well. Let me go ahead and factor out that 10. So that's going to turn this into a 10, turn this into a 1, and the 10 can go here. Ten goes there, that's a 1. Get this. Let me see. Okay, we need to get our sign straight. We factored out the e. Let's just leave this. Let's leave this as negative. Double negative there. Wait a minute, I keep missing things. We factored out the E. Okay, yeah, 10x squared, right? So that was 100. Okay, let me back up. This times this was a positive 100x squared, right? All right. Okay. I factored out the E to the negative 5x squared. Okay. Then I had the 10 times 10 was a positive 100x squared. Originally it was minus 10. Yeah, I think we're okay. So then we factored out, I think we factored out the 10, right? Yeah, I think we're okay. Okay, I think this is good. Because I had switched the order, so it was kind of throwing me off a little bit. Paste, nope. Yeah, okay, cool. All right, let's see how do we do. We got 10 e to the negative 5x squared times 10x squared minus 1. Let's see. There's the first one. Did we get that? Negative 10x. Okay. 10 e to the negative 5x squared times 10x squared minus 1. I think this is exactly. Yeah, okay. All right, that was fun. So let's look at this example. So Frankel's Fishing Emporium invested $50,000 into an account that earns 1.25% annual interest, compounded continuously. The value of the account after 2 years is given by this. So then find A of 5 and A prime of 5 and interpret the meanings. Okay. So the future value is given the future value after 5 years is A of 5. And then the annual growth rate based on 5 years, I think it's A prime of 5. Let's go ahead and find A prime. So then A prime of T is the 50. The derivative of E is itself times the derivative of the exponent. So that's just going to be times 0.0125. Okay. So then we're going to use our calculator for A of 5. It's 50 e to the 0.0125 times 5. And then A prime of 5. That's the annual rate of growth. That's going to be the 50 e to the 0.0125 times 5 times 0.0125. Okay. So we'll just, more than likely it's going to be an approximation. So let's see, for the first one, $50, 1, 2, 3 times 2, 5 times 5. That gives us 53, 224, and approximately 72 cents. Okay. And then for the next one, I'm going to kind of recall what I have. 50 e to the power of 0.0125 times 5. Then we need to say times, I think it's just the 0.0125. Okay, so that's the annual rate of growth per year. 665.32. Okay. So after 5 years, there'll be 50. So it would have earned $3,224.72 with an annual rate of growth of $665.32 per year. Okay, I think we got that one. So after exactly 5 years, the value of Franklin's Fishing and Aquarium account is going to be $53,224.72. And at that instance, the value is growing at a rate of $665.31 per year. Okay. So quick summary, the derivative of E is itself, you see it here. And then when you have E to the power of some function, that derivative is going to be itself times the derivative of that exponent. Okay. All right, so hopefully this is okay. On that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Take care, guys. Peace.